So this is a law of sines and cosines sample problem 1. So here I have a diagram. So again, this is the first question here. So this is a triangle that's given to us, and we know that this is 16 inches. We know this length is 18 inches, and we know that this is 12 inches. And we know that this angle is x, this angle is y, and this angle is z. So this is what we're given. And clearly by looking at this, we know that this is SSS, right? Side, side, side. And again, when you have all the sides given, it's always wise to use the law of cosines. So the question states that we really want to find each of these angles x, y, z, and so really when we're looking at these types of problems, we want to try to find all the sides and all the angles if we possibly can. So we are given these three sides, and we want to find the angles x, y, and z. So the first step here, it's always better, if you haven't heard of this already, you always want to look at the smaller sides. So here we know the two smaller sides are 12 and 16. If you do recall, it was a rule that states that the sum of the smaller sides, so in this case 12 and 16, must be greater than the larger side in order for this to be a triangle. So 16 plus 12 is 28. 28 is greater than the longest side, which in this triangle is 18. Therefore, this is a triangle. At times, what happens is, your answer just may be that there's no triangle, it doesn't exist. But this does prove that there is a triangle, because 16 plus 12, 28 is greater than 18. Now the other thing that you want to check is you want to square the 12 and the 16, right? So let's just do that. So 12 square plus 16 square. And we don't know if that is greater than or less than or equal to 18 square. Now if this 12 square plus 16 square does equal 18 square, then it's a right angled triangle. If 12 square plus 16 square is greater than 18 square, then this is an acute triangle where all the interior angles of the triangle are acute angles. And if 12 square plus 16 square is less than 18 square, then this would be an obtuse triangle, where you would definitely be seeing one angle that is greater than 90 degrees. So you can replay this video again and write those three rules down, because it's highly critical that you understand what type of triangle it is. Because again, if you recall from the unit circle, you may have sine of 30 degrees. Sine of 30 degrees and sine of 150 degrees. 150 degrees are the exact same thing. They give you the exact same value, because all students take calculus, right? All students indicates that the first two quadrants take any sine value, right? And if you take the sine of a value in the second quadrant and its reference angle matches to the angle we're talking about in the first quadrant, then obviously those two ratios will be equivalent. And so we don't exactly know then that which angle should we use, but we do know which angle to use if we can classify this type of triangle, whether it's acute, whether it's right, or whether it's obtuse. So solving this out, we see that this is 144 plus 256 is greater than 324. So we see that 400 is greater than 324. And the fact that the sum of the squares of the two shorter sides is greater than the square of the longer side illustrates that this is an acute triangle. And that's a good thing, because if it's an acute triangle and you really use those formulas to evaluate the side lengths or the angles, in this case, you know that all those three angles must be less than 90 degrees, and really all those three angles are part of quadrant 1. And your calculator, if you have that scientific calculator, it's automatically going to give you angles that are in the first quadrant, not necessarily in quadrants 2, 3, or 4. So it's an acute triangle, and we just say that's the normal way of answering the problem. So now what we want to do is we want to look at the law of cosines again, because we're given those three side lengths. So if we use the formula, we know that 18 square is equal to 16 square plus 12 square minus 2 times 16 times 12, and then we have cosine of x. So this is what we have here, right? And it makes sense, because again, 18 square, and then this x here must be the angle that is opposite the side length of 18, and x is opposite side length 18 here. And so this means we did this is the correct way of finding the measure of angle x. And so if we further evaluate this, we obviously want to bring the 16 square minus and the 12 square there, so we have 18 square minus 16 square minus 12 square, and we have all of that over negative 2 times 16 times 12. That is equal to cosine of x, right? And so you see that negative 76 divided by negative 384 is equal to cosine of x. Right? If you want to put those in your calculator, you can. And then you really want to do cosine of negative 1. Again, the inverse of this, which is just 76 divided by 384. That is equal to x. And so x, in this case, is equal to 78.6 degrees. So that's the value of x here. Right? So we know what... we know this is 78.6 degrees, and clearly we can further use the law of cosines. I just feel it's a little bit more time consuming than the law of sines. I prefer the law of sines, but you have this angle here. And so now if you want, you can use the law of cosines and just, make sure that instead of having 18 you take 12, and then you can find y. Take 16 squared and then you can find z, cosine of z. But I just want to show you how you can now apply the law of sines. So we know this is an acute triangle, right? All of the angles must be less than 90 degrees. Looking at this, we know that 78.6 degrees is measure of x, right? So now we can say that sine of 78.6 degrees divided by 18 must equal sine of z divided by 16. And so what this indicates is that 16 times sine of 78.6 degrees, right, is equal to 18, because you're cross multiplying, is equal to 18 times sine of z. And so we're really just doing that divided by 18 is equal to sine of z. So that means sine of negative 1. Again, the inverse of this must equal z. So that's the idea. And when we evaluate this, you can put this in your calculator, you will see that z here gives you 60.6 degrees. So z here is 60.6 degrees. And obviously you can use the law of sines or cosines to find y, but the easiest method would be to just add these two, 78.6 and 60.6, and subtract the summation from 180 degrees, as the sum of all interior angles in your triangle is 180 degrees, and you will see that y is equal to 40.8 degrees. So here we have, basically we have found all the angles and the side lengths, or the side lengths were given, but we have found all the angles of this triangle. So that's sample problem 1. In the next lesson I will be going over sample problem 2. So thanks for watching.